Oh, hi there. You must be here to learn about two-step mole conversions. Well, I am too. So, to get things started, you are going to need the following things. You're going to need a real calculator. You're going to need your periodic table. You're going to need your dimensional analysis foldable and something to write with and a piece of paper. So, go ahead and pause this video and go ahead and get those things: calculator, foldable, and periodic table. Okay, pause, and then when everybody's ready, start it again, and we will get these notes done. Okay, now that you are ready, you are going to need to write on the top of this, Unit 5. See, is that good? Okay. Unit 5 notes. These are going to be multi-step mole conversions. Okay, so last week we were able to, on Friday, we were able to do a few different conversions that were one step. We could go from a mole to atoms or molecules. You should be following along, writing this down with me. We were also, so we could do that with 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. We also had some problems where we would go from a mole of something to the mass in grams. To do that, we knew that 1 mole of anything, or of any element or compound, is equal to the molar mass of that element or compound. And then we also had that, can you see down here? Okay. That we could go from a mole of gas to a volume of gas using the equality that 1 mole of gas is equal to 22.4 liters at standard temperature and pressure. Okay, what happens though? So these are our 3 conversion factors, or equalities. A mole equals 22.4 liters of gas. 1 mole of any element or compound is equal to the molar mass of the element or compound. This we get from the periodic table. And then 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. What happens though if we are asked, how do we go from mass to atoms or molecules? That is going to take 2 steps. We're going to have to go from mass to moles, then moles to atoms or molecules. And that's what we're going to do a couple example problems of here right now. So let's start with example 1. Hope I didn't erase that too fast. Okay, example 1. The average human has about 6 grams of iron in their body at any given time. So we're going to see how many atoms of iron that actually is. So the problem would be, how many atoms of iron are in 6 grams? Oh, you can't see that. Yeah, there you go. How many atoms of iron are in 6 grams? Okay. Our target. Step 1 on our foldable is our target. Determine your target is atoms, because that's what we're wondering. That's what we want to get to eventually. Our given is 6 grams. And then it's 6 grams of iron. So 6 grams Fe. We also have some other givens that we can use that we added to the back of our dimensional analysis down here last Friday. First, that 1 mole of anything is equal to 6.02 times 10 to the 23rd atoms. And then we also know that 1 mole of iron is equal to the molar mass of iron. To get the molar mass of iron, I'm going to look at, not that, at my periodic table. I'm going to find iron on it. There's iron, it says 55.85, so I'm going to round that to 55.9. 55.9 grams. So now I've got my target units, which are atoms. I also have grams, so I'm going to go from grams to moles, then moles to atoms. Okay, step 1 and step 2, target given. Step 3 is to set up your units so that they cancel out. Your goal in life is to cancel out your units. So we always start with our given, which is 6 grams. Goes into our first box, 6 grams of iron. We're going to set this up so that we cancel units. Wish the glare wasn't there. Okay. We know that 1 mole of iron is equal to 55.9 grams of iron. So I'm going to put grams on the bottom so that my units cancel. And 1 mole of iron on the top, or just 1 mole. So now my grams of iron will cancel, and I'm left in moles. I'm not quite at my target yet, but I can use this conversion. 1 mole equals 6.02 times 10 to the 23rd atoms. 1 mole is equal to 6.02 times 10 to the 23rd atoms. Check that my units all cancel. To solve, I'm going to multiply across, divide down. Multiply across, divide down. So it's going to be 6 times 1 divided by 55.9 times 6.02 times 10 to the 23rd divided by 1. So in your calculator, right now, do it with me. It's going to be 6 times 1 divided by 55.9 times, remember when we put this number in our calculator, it's going to be 6.02 E23 and I get a really big number, but that makes sense because we're talking about atoms and atoms are really small. 6.46 times 10 to the 22nd atoms. And then atoms of what are we talking about? We're talking about iron. Atoms of iron in the average human body. Cool, huh? I think that's cool. All right. I'm going to have to pause this video because 3rd hour is actually about to start. In the second video that your sub will turn on in a few minutes, we're going to do 1 or 2 more example problems. And then you guys are going to work on practice number 9. All right, bye.